Okay, here we have another dilution problem. Again, we are adding water. So that's a good idea that it's a dilution. And it's a dilution of an acid, which makes things easier. Both those pHs are less than 7. So if we're using our little chart to organize information, we're given the pHs before we dilute and after we dilute. The after we dilute one should be closer to 7, closer to neutral. We want to know how much water should be added. We know that we start with 60 mils. So I'm going to be able to solve for V2, but that's not my final answer. And we'll come back to why. I can't just plug my pHs in because the formula is M1V1 times M2V2. pH is not the same thing as molarity. To find my molarity, we want the molarity of H plus since we're diluting an acid. To find the molarity of H plus from pH, we do 10 to the negative pH, 10 to the negative pH. So you can actually just type those numbers directly into your calculator if you want in the formula, or if you want to solve for them first, you can. 10 to the negative 3.3, I get 0.0005, 3 zeros. 10 to the negative 4.3, I get 1 more 0. Sorry about the bell. M1V1, M2V2, M1, V1, M2, V2. I'm going to be able to solve this for V2. So 0.0005 times 60 divided by the one with 4 zeros. And I get 598.6. I kept everything exactly in my calculator, but you should be getting somewhere close to 600. I'm going to go ahead and just say 599. I rounded it. That is my V2. If you got that and you thought you're wrong, you're not wrong. You're just not done. Remember that V2 represents the volume after we dilute it. It represents the whatever we started with and the water that we added in order to dilute it. So the fact that they are asking just how much water was added, what we need to do is from this 599, we need to subtract out 60. And I'm getting 539 now. It all depends on how you round, but somewhere close to 540 is fine. But I take the 599, I subtract out the 60 because I only care about the water. I don't care about the whole total volume after dilution.